Okay, let's dive straight into this explainer. Today, we're talking about ditching DEET, the science of using catnip as a high-efficacy mosquito repellent. Now, what if I told you that a common garden weed, the one famous for making cats act completely crazy, is actually challenging the world's standard for mosquito repellent? We are looking at some truly groundbreaking research today, spanning everything from molecular dynamics all the way to rural community economics. So if you think you already know all there is to know about fighting mosquito-borne illnesses, well, prepare to have your perspective shifted. I mean, it sounds kind of like a myth, right? But we are looking at hard, peer-reviewed science today. We're totally moving past folklore to see how a local, easily cultivated plant could actually be a massive disruptor in global health. 610,000. That massive number represents the global malaria deaths in 2024 alone. It is a staggering figure. Malaria, a disease spread primarily by mosquitoes, infects roughly 282 million people every single year. And the tragic part? Those 610,000 deaths disproportionately affect young children in African countries. So the stakes for finding an effective, genuinely accessible preventative measure, they literally could not be higher. Here is our roadmap for today. First, the mosquito repellent dilemma. Second, catnip's secret chemical weapon. Third, lab-to-field trials. And finally, a self-sustaining enterprise solution. Let's start with Section 1, the mosquito repellent dilemma. So we all know DEET, right? Or N-diethylmetatylamide, if you want to get technical. It is highly effective and widely considered the absolute gold standard for insect repellents. But here's the thing. Buying commercial repellents is just not a practical or affordable reality for the communities who are most at risk. For rural Ugandan subsistence farmers, a standard bottle of DEET is completely out of their price bracket. It's a textbook and, quite frankly, deeply frustrating example of a life-saving tool that fails to reach the people who actually need it the most simply because of economic barriers. Moving on to Section 2, catnip's secret chemical weapon. The real star of the show here is a chemical compound called Nepetalactone. Basically, it's an iridoid monoterpene, which is just a fancy way of saying it's a naturally occurring botanical chemical, and it makes up over 95% of catnip's essential oil. Now, researchers have actually known about its insect-repelling properties for a long time. However, Big Pharma has largely ignored it. Why? Well, because you can't easily patent a naturally occurring plant compound. And the irony of this plant is just brilliant. The exact same chemical that causes intense euphoria in cats acts as a potent deterrent for mosquitoes. Research indicates that nepetalactone specifically activates TRPA1 irritant receptors in insects. Think of it like a blaring, deafening fire alarm for mosquitoes. It triggers a massive aversion response, making them want to flee instantly, but it doesn't bother us humans at all. Zooming all the way into the microscopic level, molecular dynamics studies show how these plant-derived molecules actively interact with and disrupt odorant-binding proteins, or OBPs, in mosquitoes. You can kind of think of OBPs as the mosquito's internal radar or sense of smell. Whether we're talking about Aedes aegypti, which carries dengue, or Anopheles gambia, the primary malaria vector, molecular docking simulations prove that nepetalactones jam this radar just as effectively as synthetic chemicals. It completely blocks their ability to seek out human hosts. Let's look at Section 3, Uganda trials, from the lab to the field. To see how this holds up in real-world muddy boots field conditions, a dedicated team of plant researchers from Wales and Uganda partnered up. Their goal was to rigorously test a homegrown, nepetalactone-rich catnip oil against that DEET gold standard we talked about. And this wasn't just some lab experiment isolated in the global north. This was a deeply collaborative effort involving Cardiff University, Makerere University in Uganda, and a local community organization known as CMPOP. They mapped out a really strict methodology to prove the efficacy. Step 1 was a highly controlled Y-tube olfactometer lab test. That's essentially a standard binary choice assay where mosquitoes literally have to choose between a treated and an untreated path. Then, Step 2 took it straight to the field in the Badaka district of eastern Uganda. This involved the human land and catch assay, which, yes, literally means incredibly brave volunteers sat out in the evening with one treated and one untreated leg, acting as human bait to count the number of wild mosquitoes that actually tried to bite them. The data from those trials reveals a genuinely crucial point. A 6% catnip oil formulation was just as effective at repelling mosquitoes as the 15% DEET standard. no difference in efficacy. And even more remarkably, a highly cost-effective 2% concentration of the catnip oil was only marginally less effective than the DEET. This completely proves that you don't need high, expensive concentrations of this essential oil to achieve world-class protection. Now, while DEET generally does last longer on the skin, this 2% catnip formulation still provides a solid 4 hours of statistically significant protection. And for people living in rural malaria-endemic regions, 4 hours is actually highly practical. It provides a perfect window of protection for those evening hours when chores are being done outside and when many species of mosquitoes are at their absolute most active. Finally, Section 4, a self-sustaining enterprise solution. Dr. Simon Schofield from Cardiff University summed up the ethos of this entire project perfectly. This is not just about parachuting a scientific solution into a community from the outside. It's about prioritizing both health equity and economic empowerment. By using a plant that is easily cultivated right there locally, the entire production cycle remains entirely in the hands of the people using the product. Through CEM-POP, which stands for the Community Enterprise Model for Plant Oil Production, they actually created DSK Lotion. Named after a local community leader, this product utilizes that widely cultivatable catnip. The oil is super easy to extract via simple hydrodistillation, and users actually report it smells far more pleasant than DEET. But most importantly, unlike those wildly expensive bottles of DEET, selling this for a small price keeps money flowing directly back into the local community to pay the workers producing it. It's a win-win. But we do have to be impartial here and look at the trade-offs presented in the research. Plant-based oils like catnip have higher volatility, meaning they evaporate faster than synthetic chemicals. So this means strict user compliance is an absolute must for this to work as a primary malaria-fighting tool. If you forget to reapply it after that 4-hour mark, your risk definitely spikes. As we wrap up this explainer, I really want to leave you with this final thought. We've seen how a common weed, one that basically just makes cats playful, can stand toe-to-toe with the world's leading chemical repellent, all while empowering local economies. It really makes you wonder, doesn't it? What other life-saving solutions are just waiting to be discovered right in our own backyards, ready to challenge the entire status quo of global health? Thanks for joining me on this deep dive, and as always, keep questioning what's possible.